We launched JUNO in August of 2011. It finally gets to Jupiter on the 4th of July, 2016. So 5 years to get there. And then after a couple of orbits to set things up and so forth, in October of 2016, we start science orbits that are every 2 weeks for 33 orbits. So a bit more than a year, almost a year and a half at Jupiter.
It's a pretty sizable spacecraft. The tips of the arrays, as they rotate around, since we're a spinner, would reach rim to rim on an NBA basketball court. Why do we go to Jupiter besides the exciting aspect of exploration? In our case, it pertains to us obtaining a better understanding of how the solar system formed, because Jupiter was one of the earliest planets to form. Most of the mass outside of the Sun is at Jupiter. And because it's a gaseous giant, it really hasn't changed that much, so we can learn a lot more by studying Jupiter to determine how the solar system formed and indirectly not only Jupiter but also Earth.
It's one of the very first objects ever studied with a telescope. Galileo looked at Jupiter and discovered the Galilean moons of Jupiter, and yet, what's it made out of? What's it look like on the inside? How did it form? Those are still questions we're working on. We don't know the answers to those. When we look at Jupiter's magnetosphere, it's got this huge magnetic field. It's got high energy particles trapped in the magnetic field, radiation that make it one of the most hazardous places in the solar system. And we understand a lot about that magnetosphere and the radiation belts and all, but we don't understand some basic stuff about how that works. We see a ring in the north and a ring in the south of auroral lights that are from electrons streaming down the magnetic field and hitting the upper atmosphere of Jupiter. Exactly how those currents work, how many electrons at what energies, those are things we don't know yet. Certainly one of the greatest mysteries of Jupiter and a real puzzle that we're trying to understand is, how did it form? When you look at the solar system and you say, how did we make a solar system? The general idea of we started with a cloud of gas and dust, and gravity made it collapse and it formed a star, and the little tiny dregs left over, the 0.5% left over, made the planets. That basic picture works. But when you look at it in detail and you say, what formed first? Did Jupiter form from the initial cloud of gas and dust, or did it form in smaller chunks that collided together and stuck and made a giant planet? Usually when we study other planets, one of the things we talk about is comparative planetology. If you want to understand planets in general, it helps a lot to be able to compare one planet to the next. And that's certainly going to happen here, and there's a lot of value there. Jupiter all by itself, in terms of mass, is most of the planets in the solar system. And furthermore, it must have formed first, because it's hard to see how it could have formed at all if the other planets had formed first. So Jupiter is a big piece of the puzzle. It probably affected the formation of all the other planets in the solar system. So if you want to ask the question, where do we come from? In a lot of ways, a big part of the answer to that question lies not in our planet, but in Jupiter. Those are some of the things that we want to explore with our spacecraft.